Hello, in this lecture we will find the diameter of the semicircle. In the drawing we have a semicircle. AB is the diameter of the semicircle. Chord AD equals to 7 units. Chord DC equals to 15 units. Chord CB also equals to 15 units. And we want to find out the value of AB, or the size of AB, that is the diameter of this semicircle. So first of all, we will make a construction. We will join together by a straight line points D and B, these 2 points. Actually, angle ADB, the peripheral angle ADB, is a right angle. It equals to 90 degrees. According to rule number 1, that states that a peripheral angle resting on the diameter of the circle equals to 90 degrees. So I will read rule number 1 again. Rule number 1 states that a peripheral angle resting on the diameter of the circle equals to 90 degrees. So actually, angle ADB is a peripheral angle that rests on AB, and AB is the diameter of this semicircle. It has given us that AB is the diameter of the semicircle. Therefore, angle ADB equals to 90 degrees according to rule number 1. So angle ADB equals to 90 degrees according to rule number 1, it states that the peripheral angle that rests on the diameter of the circle equals to 90 degrees. This peripheral angle ADB, rests on the diameter AB of the semicircle. Therefore, according to rule number 1, it equals to 90 degrees. Okay, in the next step, we will define the center of this semicircle as point O. So this point is point O, the center of this semicircle, and then we will join together points O and C by a straight line. And we will also join together points O and D by a straight line. And we will focus on triangles OCD, the green triangle, and we will also focus on triangle OCB, this triangle, the orange triangle, triangle OCB. Okay, so in triangles, the green triangle, triangle OCD, and the orange triangle, triangle OCB, we know that side TC of the green triangle equals to side CB of the orange triangle, and both those two sides are equal to 15 units in their size, in their sizes. Okay, DC equals to CB equal to, okay, DC equals to CB equals to 15 units. And actually OD is the radius of this semicircle, because line segment OD starts from the center of this semicircle and ends at point D, that is a point on the semicircle itself. Therefore, OD is the radius of this semicircle. We will mark the radius of this semicircle as R, and also OB is the radius of this semicircle for the same reason. It starts from the center of the semicircle, that is to say from point O, and ends at point B, that is a point on the semicircle itself. Therefore, OB is the radius of this semicircle. So actually, side OD of the green triangle equals to side OB of the orange triangle, and both those two sides are equal to the radius of this semicircle. So again, side OD of the green triangle is equal to side OB of the orange triangle, and both those two sides are equal to the radius of this semicircle. Okay, so actually they are equal to each other, and because they are equal to the radius of this semicircle. And also OC is a common side. It belongs both to the green triangle, and OC also belongs to the orange triangle. So OC equals to OC. Actually, it is a common side. It belongs to both triangles, to the green triangle and to the orange triangle. Okay, again, OC equals to OC. It is a common side. It belongs to both triangles. So actually, we proved that all the sides of the green triangle are equal to all the sides of the orange triangle. Therefore, we actually proved that the green triangle DOC is congruent to the orange triangle OCB. Okay, again, the green triangle OCD is congruent to the orange triangle OCB, according to side rule. Okay, so those two triangles congruent to each other according to side rule. Side rule states that if all the sides of one triangle are equal to all the sides of another triangle, then those two triangles are congruent to each other according to side rule. Okay, so from the fact that those two triangles congruent to each other, we can deduce or derive that angle OCD is equal to angle OCB. Okay, those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. The green triangle is congruent to the orange triangle, therefore the corresponding angles, that is to say those two angles, are also equal to each other. So angle OCD of the green triangle is equal to angle OCB of the orange triangle, and if we define angle OCD as alpha, then angle OCB will be also equal to alpha, because those two angles are equal to each other. Okay, so again, angle OCD is equal to angle OCB, and both those two angles are equal to alpha according to our definition. Okay, in the next step we will focus on triangle DCB, this triangle. in triangle DCB, side DC of triangle DCB is equal to side CB of the triangle DCB, and both those two sides are equal to 15 units according to what is given us in the question. Again, in triangle DCB, side DC of the triangle is equal to side CB of the triangle, and both those two sides are equal to 15 units. Okay, according to what is given us in the question. Okay, here actually we have rule number 2. Rule number 2 states that in front of equal sides in the triangle, there are equal angles. So I will read rule number 2 again. Rule number 2 states that in front of equal sides in the triangle, there are equal angles. So actually, in triangle DCB, we have two sides that are equal to each other. DC equals to CB. According to rule number 2, in front of equal sides, there are equal angles. So in front of this side BC, we have angle D. Here we define this point as point E. So actually, in front of this side we have this angle that is actually angle CDE, and in front of this side we have angle CBE, so according to rule number 2, those two angles that are located in front of equal sides are also equal to each other. That is to say, angle CDE of the orange triangle equals to angle CDE of the green triangle is equal to angle CBE of the orange triangle. Those two angles are equal to each other because they are located in front of equal sides. And if we define angle CDE as theta, then angle CBE also will be equal to theta because of the fact that those two angles are equal to each other according to rule number 2. So here angle CDE equals to angle CBE, and both those two angles are equal to theta, so the equality is according to rule number 2. And both of those two sides are equal to theta according to our definition. In the next step, we will focus on two triangles. On the green triangle, triangle CDE, And we also will focus on the orange triangle, triangle CEB. Again, we'll focus on the green triangle, triangle CDE, and on the orange triangle, triangle CEB. On those two triangles. First of all, we know that side DC of the green triangle is equal to side CB of the orange triangle, and both those two sides are equal to 15 units in their sizes. Okay, side DC of the green triangle is equal to side CB of the orange triangle, and both those two sides are equal to 15 units in their sizes. Okay, and we also know that those two angles are equal to each other, that is to say, angle DCE in the green triangle is equal to angle ECB in the orange triangle, and both those two angles are equal to alpha according to our definition. Again, angle DCE in the green triangle is equal to angle ECB in the orange triangle, and both those two angles are equal to alpha according to our definition. Okay, and angle CE is a common angle, side CE. Side CE is a common side. It belongs to both the green triangle, and side CE also belongs to the orange triangle. So CE equals to CE is a common side. So we actually proved that two sides and the angle included in the green triangle are equal to two sides and the angle included in the orange triangle. Therefore, we proved that those two triangles are congruent to each other according to side angle side rule. Okay, so I write it down. Triangle, the green triangle, triangle DCE is congruent to the orange triangle, triangle ECB. According to side angle side rule. Again, the green triangle, triangle DCE, is congruent to the orange triangle, triangle ECB, according to side angle side rule. Again, side angle side rule states that if you prove that two sides and the angle included of one triangle is congruent to two sides and the angle included in the other triangle, then those two triangles are equal to it, are congruent to each other, or you can say that if two sides and the angle included in one triangle are equal to two sides and the angle included of another triangle, then those two triangles congruent to each other. That is actually side angle side rule. And those two triangles congruent to each other according to side angle side rule. So actually, from the fact that triangle DCE is congruent to triangle CEB, we can conclude that angle DEC in the green triangle is equal to angle CEB in the orange triangle, according to the rule that states that corresponding angles in congruent triangles are equal to each other. So I'll write it down. Angle DEC in the green triangle equals to angle CEB in the orange triangle, according to the rule that corresponding angles in congruent triangles are equal to each other. Again, angle DEC in the green triangle is equal to angle CEB in the orange triangle. Those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. And if we define angle CED as x, then angle CEB must be also equal to x, because those two angles are equal to each other. Okay, so again, angle DEC in the green triangle is equal to angle CEB in the orange triangle, and those two angles are equal to x according to our definition. So actually, what is the size of angle DEC, angle DEB? The size of angle DEB is actually x plus x. Angle DEB equals to x plus x, that is 2x. So angle DEB, this angle equals to 2x from one side, but we also have a rule. First of all, we made the first construction in the beginning of the lecture. We connected points D and B by a straight line. So DB is a straight line. Line segment DB is a straight line. Again, line segment DB is a straight line because we created it like that. We constructed line DB Actually, by connecting points D and B together by a straight line. So DB is a straight line. And we have rule number 3 that states that the sum of the angles on a straight line is equal to 180 degrees. Again, I will read rule number 3 again. Rule number 3 states that the sum of the angles on a straight line is equal to 180 degrees. Okay, so according to rule number 3, actually angle DEB, this angle DEB, according to rule number 3, equals to 180 degrees. Okay, again, according to rule number 3, angle DEB equals to 180 degrees because of the fact that DB is a straight line, and rule number 3 states that the sum of the angles on a straight line is equal to 180 degrees. So angle DEB, according to rule number 3, is equal to 180 degrees for one side. But we have already shown that angle DEB also equals to 2x, because angle DEB consists with angle x, this angle x, and this angle x. So angle DB actually equals to 2x. So we actually have this equality, and from this equality we can derive that 2x equals to 180 degrees. Okay, 2x equals to 180 degrees. So here we will divide this equality by 2, and we will get that angle x equals to 90 degrees in its size. Okay, angle x equals to 90 degrees in its size. So actually we can substitute those two angle x by 90 degrees, because angle x equals to 90 degrees. This angle x equals to 90 degrees, and this angle x also equals to 90 degrees according to what we found right now. Those two angles are equal to x. Okay, and we actually made construction, the second construction, in the second construction we connected points O and C by a straight line. So OC is a straight line because it is our construction. We constructed OC as a straight line. So line segment OC is a straight line, and if we look on the left side of line segment OC, we know that the sum of the angles is equal to 180 degrees in the left side. Okay, according to rule number 3, the sum of the angles on a straight line, that is to say on the left side of the straight line OC, is equal to 180 degrees. So what is the sum of the angles in the left side of the straight line OC? It consists two angles. This angle is a right angle, it equals to 90 degrees, so it is 90 degrees plus this angle, that is angle OEB, we know that the sum of those two angles, according to rule number 3, is equal to 180 degrees. Again, we have this equality. That is actually, this equality states that the sum of the angles on a straight line equals to 180 degrees according to rule number 3. So here we can subtract 90 degrees from this equality, and we will get that angle EOB, angle OEB, this angle is equals to 180 degrees minus 90 degrees is 90 degrees. Okay, so we found out that this angle is a right angle. That is to say, it equals to 90 degrees. So actually, we found out that three angles around point E are right angles. This is the first angle, this is the second angle, and this is the third angle. And the sum of the three right angles around point E is equal to 90 degrees times 3 is 270 degrees, okay? I will write it down. The sum of the angles, the sum of three angles around point E is equal to 270 degrees. Okay, the sum of those three angles is equal to 270 degrees. So I'll read again the things that I wrote. The sum of three angles around point E is equal to 270 degrees. We will define the size of the fourth angle, the size of this angle as y, we actually have rule number 4. Rule number 4 states that the sum of the angles around any point is equal to 360 degrees. I will read rule number 4 again. Rule number 4 states that the sum of the angles around any point is equal to 360 degrees. Okay? And especially around point E, the sum of the angles must be equal to 360 degrees, according to rule number 4. So actually, the sum of the angles around point E will be equal to the sum of three angles that is three right angles, that is 270 degrees, plus the size of the fourth angle, that is Y. In total, the sum of those four angles must be equal to 360 degrees, according to rule number 4. Okay? Again, according to rule number 4, the sum of the angles around any point is equal to 360 degrees, and especially around point E, the sum of the angles must be around point E must be equal to 360 degrees. We know that the sum of the three angles around point E is equal to 270 degrees, plus the size of the fourth angle must be equal to 360 degrees. So that is according to rule number 4. So we can subtract 270 degrees from this equality, and we will get the value of Y. We will get that Y equals to 90 degrees. So angle Y is a right angle. Okay? So we can substitute Y by a right angle because it is a right angle. So we actually prove that all the four angles around point E are right angles. Okay, so in the next step we will focus on the right triangle, triangle ADB, and the big right triangle, triangle ADB, and the small right triangle, triangle OED. So I will draw those triangles again. Triangle ADB is right triangle because this angle is right angle, and also triangle OEB is right triangle because this angle equals to 90 degrees. So I will draw those two triangles again, those two right triangles. So here we have the right triangle, triangle ADB. So I draw again those two right triangles. So here those two angles are equal to each other, those two angles are right angles, therefore they are equal to each other. So angle ADB in the big triangle is equal to angle OEB in the small triangle, and both those two angles are equal to 90 degrees in their sizes. Okay, and angle B, this angle is a common angle. It belongs both to the small triangle, and angle B also belongs to the right triangle, triangle ADB. So you can write down that angle B equals to angle B. Both it is a common angle. It belongs to both triangles. Okay, so angle B equals to angle B. So we found out that those two angles are equal to each other, and also angle B equals to angle B. It is a common angle. And the third angle, angle DAB in the big triangle, is equal also to angle EOB in the small triangle. So those two angles are also equal to each other. I'll write it down. Angle DAB in the big triangle is equal to angle EOB. This angle in the small right triangle. Those two angles are equal to each other according to third angle theorem. Third angle theorem. Actually, third angle theorem states that if you have triangle that has two angles that are congruent to two angles of another triangle, then the third pair of angles must be also congruent. Okay, so those two angles are equal to each other according to third angle theorem. So we actually proved that all the angles in the big triangle are equal to all the angles of the small triangle. Therefore, the big triangle, triangle ADB, is similar to the small triangle, triangle EOB. Okay. Triangle ADB, the big triangle, is similar to the small triangle, triangle EOB, according to angle rule. Angle rule states that if you prove that all the angles in one triangle are equal to all the angles in another triangle, We actually proved that those two triangles similar to each other. Okay, so those two triangles are similar to each other according to angle rule. From this similarity between the two triangles, the following relationship exists between their sides. The relationship is OB, the side of the small triangle, over AB, the side, actually it is the hypotenuse of the big triangle, equals to OE the side of the small triangle, over AD, the side of the big triangle. Again, the following relationship exists between those two similar triangles. OB over AB equals to OE over AD. Okay? But what is the value of OB? OB is the radius of this semicircle, so it equals to R. And what is the value of AB? AB is the diameter of this semicircle. That is to say, it equals to 2 times the radius of the semicircle. Okay? And we also know that OA is also the radius of this semicircle. So even from the drawing itself, we can see that AB equals to 2R, that is the diameter of this semicircle. OE is OE over AD. What is the size of AD? AD equals to 7 units according to what is given us in the question. So here we have R over R. R over R is 1. So R is cancelled. So here we'll multiply this equality by 7 in order to get the value of OE. So actually OE equals to 7 over 2 7 over 2 units. Okay, OE equals to 7 over 2 units. Again, OE equals to 7 over 2 units. So we can write here that OE equals to 7 over 2 units. Again, OE equals to 7 over 2 units. And what is the value of EC? EC equals to OC minus OE. Again, EC equals to OC minus OE. EC equals to OC minus OE. And what is the value of OC? OC is the radius of this semicircle because of the fact that it starts from the center of the semicircle, that is to say from point O, and ends at point C, that is a point on the semicircle itself. So OC is the radius of the semicircle, and OE, we have already found out that OE equals to 7/2 units. 7/2. So we found that EC equals to R minus EC equals to R minus 7/2. So we can write here that EC equals to R minus 7/2 again. EC equals to R minus 7/2. So in the next step we will focus on two right triangles. Triangle CEB is a right triangle because angle CEB is a right angle, and triangle OEB is also a right triangle because angle OEB is a right angle. This is a right angle. So in those two triangles we will use the Pythagorean theorem. In those two right triangles, the Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So we'll create the equality that states that EB square equals to EB square. EB square equals to EB square. Okay, we have this equality. EB square equals to EB square, and actually EB belongs to both right triangles. It belongs to the right triangle, triangle EBC, and it belongs also to this right triangle, triangle OEB. Okay, so we form this equality that EB square equals to EB square. So here we have 2 times EB, so the first EB will be related to this triangle, triangle OEB. Here EB square is actually OB square. Minus OE square. Okay. Again, the first EB square relates to this right triangle. Here EB square equals to OB square minus OE square. And the first EB square relates to this right triangle. Here EB square equals to BC square minus EC square. Again, BE square in this triangle equals to BC square minus EC square. So in total we got this equality that OB square minus OC square equals to BC square minus CE square. But what is the value of OB? OB is the radius of the semicircle. So OB square is R square minus OE. OE equals to 7/2 units. So OE is 7/2 square is 49/4. 49/4. And what is the value of BC? BC equals to 15 units. So BC square will be equal to 15 square. 15 square is 225 minus EC square. EC equals to R minus 7 over 2 square. EC square is R minus 7 over 2 square. So in total we got this equality that R square minus 49 over 4 equals to 225 minus R minus 7 over 2 square. So here we will open the brackets. Okay, we will get that R square minus 49 over 4 equals to 425 minus 225 minus R square plus 7 over 2 R square is 49 over 4 minus 2 times R times 7 over 2. So here you have 2 in the numerator and 2 in the denominator, so 2 over 2 is 1, 2 is cancelled. So we will open the brackets here and we will get that R square minus 49 over 4 equals to 225 minus R square minus 49 over 4 minus times minus is plus 7R. So we got that R square minus 49 over 4 equals to 225 minus R square minus 49 over 4 plus 7R. So here we have minus 49 over 4 on this side of the equality, and we have minus 49 over 4 on the other side of the equality, so we will cancel 49 over 4, and then we will add to this equality R square we will get that R square plus R square is 2R square equals to 7R plus 225. Okay, so from this equality we will subtract 7R and then 225. We will get quadratic equation. It states that 2R square minus 7R minus 225 equals to 0. So we got this quadratic equation. R square minus 7R minus 225 equals to 0. We have the general formula for quadratic equation is ax squared plus bx plus c equals to 0. So that is the general formula for the quadratic equation. Ax squared plus bx plus c equals to 0. So here A, B, and C are the coefficients of this quadratic equation, and x is the variable that we want to find out. And we will find out the value of x according to a special formula for x. X equals to plus minus root of, okay, here we have minus b x equals to minus b plus minus b square minus 4 times a times c. Okay, over 2a. Okay, that is the equality for x, and a, b, and c are the coefficients of this quadratic equation, and x is the variable that we want to find out. So in our case, we have 4r squared minus 7r minus 225 equals to 0. And the coefficients of this quadratic equation is a equals to 2, b equals to minus 7, b equals to minus 7, it's c equals to minus 225, okay, we have the coefficients of our specific quadratic equation. A equals to 2, b equals to minus 7, c equals to minus 225. Okay, so, and we know also that the variable in our quadratic equation is r, so x equals to r. So we will put the data inside the equation to find out the values of r, that is the root of this quadratic equation. So x is r, so we write that r equals to minus b, b equals to minus 7, so minus 7 is plus 7, plus minus root of b square, b is minus 7, so b square is 49, minus 4 times a is minus 8, is 49. Okay. 4 times a is 4 times 2 is minus 8 times minus 2 c is 225 over 2a, a is 2, so 2a is 4. So in total we got this equality for y, for r. So we got actually that r equals to 7 plus minus r equals to 7 plus minus r equals to 7 plus minus root of b square. So here we found out that 49 minus 8 times minus 225 is 1800. So in total we got that this is 49 plus 1800 over 2a. A is 2, so 2 times 2 is 4. So in total we got that the radius of this semicircle is r equals to 7 plus minus root of 1800 plus 34, root of 1834 is r equals to 7 plus minus root of 1849 over 2 times a is 4. So r equals to 7 plus minus root of 1849 is 43 over 4. Okay, so we have one solution, that is r equals to 7 plus 43 is 50. 50 over 4 is 12.5. So the first solution is that the radius of the semicircle equals to 12.5 units. But we have another solution that states that r equals to 7 minus 43 over 4 is 7 minus 43 is minus 36 over 4 is minus 9. So we grant that the radius of this semicircle equals to minus 9, but it is incorrect answer, because the radius of the semicircle is a positive number, and it can never be a negative one, so it is incorrect, and we left only with the solution that r equals to 12.5 units, and the diameter of the semicircle is AB. AB is the diameter of the semicircle. It equals to 2 times the radius, that is actually 2 times 12.5, that is actually 25 units. Again, the answer to the question is that the diameter of the semicircle is 25 units. D equals to AB equals to 2R equals to 25 units. Okay. Again, the diameter of this semicircle AB equals to 25 units. It is also 2 times the radius of this semicircle. Okay, now I will summarize the lecture. Actually, we wanted to find out the diameter of this semicircle. It is actually AB. We want to find out the size of AB. Okay, and first of all, we made a construction we actually connected together points P and D by a straight line, and peripheral angle ADB is created by this construction, and peripheral angle ADB equals to 90 degrees because of the fact that it rests on AB, that is the diameter of the semicircle, and we have rule 1 that states that a peripheral angle resting on the diameter of the circle equals to 90 degrees. So angle ADB rests on AB, that is the diameter of the semicircle. Therefore, according to rule number 1, it equals to 90 degrees. This angle equals to 90 degrees. Then we defined the center of this semicircle as point O, and then we connected together points O and C by a straight line, and we also connected together points O and D by a straight line. So then we focused on the green triangle, triangle ODC, and on the orange triangle, triangle OCB. Okay, first of all, in those two triangles, again, the green and the orange, DC equals to CB equals to 15 units. It is given us in the question. DC equals to CB equals to 15 units, and also OB equals to OD equals to the radius. Okay, so OB equals to the radius of the semicircle, and OC is actually a common side. It belongs to both those two triangles. So OC equals to OC. So in this way we actually proved that all the sides of the green triangle are equal to all the sides of the orange triangle. Therefore, those two triangles can go into each other. Okay. One can also say that the green triangle, triangle DOC, can go into the right triangle, to the orange triangle, triangle DCB. Okay. According to side rule. Side rule states that if you prove that all the sides of one triangle can go into all the sides of another triangle, then those two triangles can go into each other according to side rule. Okay. Then from the fact that those two triangles can go into each other, we can conclude that those two angles are also equal to each other, according to the rule that corresponding angles in congruent triangles are equal to each other. And those two angles are the corresponding angles in the green triangle that is congruent to the orange triangle. And so angle BCD equals to angle OCB equals to alpha according to our definition. Those two angles are equal to alpha and they are equal to each other. Then we focused on triangle DCB. On this triangle DCB, side DC equals to side CB. Both those two sides are equal to 15 units. So DC equals to CB equals to 15 units. And we have rule number 2 that states that in front of equal angles in the triangle, there are equal, in front of equal sides in the triangles, there are equal angles. Okay? In front of equal sides in the triangle, there are equal angles. So actually, in triangle DCB, we have two sides that are equal to each other. In front of this side, we have this angle. In front of this side, we have this angle. So those two angles that are located in front of equal sides are also equal to each other. Okay, therefore, angle CDE equals to angle CBE according to rule number 2. Those two angles, angle CDE are equal to angle CBE according to rule number 2, because in front of equal sides are equal angles, so those two angles are equal to each other. And if we define this angle as m theta, then this angle also will be equal to theta, because those two angles are equal to each other. So angle CDE equals to angle CBE, and both those two angles are equal to theta. Then we define this point as point E, and we focused on triangle CDE and on the other triangles, triangle CBE. On those two triangles, we know that DC equals to CB, and both those two sides are equal to 15 units. It is given us in the question. And those two angles are equal to each other. We have already found out that those two angles are equal to each other, and also CE is a common side. It belongs both to the orange triangle and to the orange triangle and to the green triangle. So EC equals to EC. So we actually proved that two sides and the angle included in the green triangle are equal to two sides and the angle included in the orange triangle. Therefore, we proved that those two triangles congruent according to side angle side rule. Okay? Those two triangles congruent according to side angle side rule. And so because of the fact that those two triangles congruent to each other, those two angles equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Okay? So if we define this angle as x, then this angle also will be equal to x. Okay? So actually angle DEB equals to x plus x, that is 2x. Angle DEB equals to 2x. Okay? And we know that DB is a straight line because we connected points D and B by a straight line. So DB is a straight line. And we have rule number 3 that states that the sum of the angles on a straight line is equal to 180 degrees. So DB is a straight line, and we know that the sum of the angles is equal to 180 degrees according to rule number 3. Therefore, angle DEB, this angle DEB is equal to 180 degrees. Again, from one side, angle DEB equals to 180 degrees according to rule number 3, that the sum of the angles on a straight line is equal to 180 degrees. But from the other side, angle DB consists from two angles, x and x. So angle DB equals to x plus x, that is to say it equals to 2x. So from one side angle DEB equals to 2x, and from the other side angle DEB equals to 180 degrees according to rule number 3. We can derive from this equality that 2x equals to 180 degrees, and if we divide this equality by 2, we will get that x equals to 90 degrees. So actually this angle is a right angle and this angle is also a right angle. Then we focused on OC. OC is a straight line because we connected together points O and C by a straight line. That is, for that reason OC is a straight line. So again, we have rule number 3 that states that the sum of the angles in a straight line equals to 180 degrees. So if we look on the left side of the straight line OC, on the left side, we, according to rule number 3, the sum of the angles on the left side of the straight line OC is equal to 180 degrees. That is according to rule number 3. So what are the sum of the angles in the left side of the straight line OC? It is a right angle plus angle OEB. So according to rule number 3, this angle, that is a right angle plus angle OEB, this angle must be equal to 180 degrees. Again, this angle plus angle OEB must be equal to 180 degrees. The right angle plus angle OEB must be equal to 180 degrees according to rule number 3 that states that the sum of the angles on a straight line is equal to 180 degrees. And here we relate to the left side, the sum of the angles on the left side of the straight line OC equals to 180 degrees. So we have this equality. From this equality we subtracted 90 degrees and we found out that angle OEB is a right angle. So this is a right angle. Okay, so actually we have 3 right angles around point E, that the sum of those 3 right angles is 90 times 3 is 270 degrees. So around point E we have 3 right angles that the sum of them is 270 degrees. And we define angle OED as y. The size of angle OED is y. And we have rule number 4 that states that the sum of the angles around any point is equal to 360 degrees. So, and especially around point E, the sum of the angles must be equal to 360 degrees according to rule number 4. So the sum of the angles around point E must be equal to 360 degrees. The sum of the 3 angles, that is 270 degrees, plus the size of the 4th angle must be equal to 360 degrees according to rule number 4. So from this equality we can subtract 270 degrees and we will get that y equals to 90 degrees. So we found out that this angle is also a right angle. So we actually found out that all the angles around point E are right angles. Then we focused on the right triangle ADB on the right triangle EOB. And triangle ADB is a right triangle because angle ADB is a right angle, and triangle OEB is a right angle because angle OEB is a right angle. So actually those 2 angles are equal to each other, they are equal to 90 degrees. And therefore they are equal to each other. Angle ADB of the big triangle equals to angle OEB of the small triangle. Both those 2 angles are equal to 90 degrees. And angle B is a common angle. It belongs to both the triangle OEB and it belongs also to triangle ADB. So we can write down that angle B equals to angle B. It is a common angle. And the third pair of angles, that is to say angle DAB in the big triangle equals to angle EOB in the small triangle, according to third angle theorem. The third angle theorem states that if you have two triangles that are congruent to each other in two angles, then the third pair of angles must be also congruent according to third angle theorem. So the third angle, those two angles also equals to those angles according to the third angle theorem. So we actually proved that all the angles in the big triangle are equal to all the angles in the small triangle. Therefore, we actually proved that those two triangles are similar to each other according to angle similarity. Okay, angle rule. Those two triangles are similar to each other according to angle rule. From the similarity, we can derive the following relationship between the sides of those two similar triangles. OB over AB equals to OE over AD. Again, OB over AB equals to OE over AE over AD. Okay, OB over AB equals to OE over AD. But what is the size of OB? OB is the radius of the circle. AB equals to R plus R. If the diameter is 2 times the radius, it equals to 2R. OE is OE, and what is the size of AD? AD equals to 7 units. So in total, we got this equality. Here we can, R over R is 1, so we got that OE equals to 7 over 2 units. The size of OE equals to 7 over 2 units. And then the size of EC is OC minus OE. OC is the radius, OE is 7 over 2, so in total EC equals to R minus 7 over 2. Then we related to those two right triangles. Triangle CEB is a right triangle because this angle is right angle, and triangle OEB is a right triangle because this angle is a right angle. We implemented the Pythagorean theorem on those two right triangles according to the statement that EB square equals to EB square. You should remember that EB belongs to both two triangles. EB belongs to the right triangle EOB, and EB also belongs to the right triangle EBC. So the first EB square relates to this triangle equals to, according to the Pythagorean theorem, EB square equals to OB square minus OE square. EB square equals to OB square minus OE square. And the second EB square is related to this right triangle. It equals to CB square minus CE square. Equals to CB square minus CE square or AC square. But we know that OB equals to R. OE equals to 7 over 2, so OE square is 49 over 4. BC equals to 15, so BC square is 15 square is 225. And EC equals to R minus 7 over 2. So EC square is R minus 7 over 2 square. So we solve this simple equality and we arrived to the quadratic equation that 2R square minus 7R minus 225 equals to 0. We have the general formula for the quadratic equation, and the solution of this quadratic equation when a, b, and c are the coefficients of this quadratic equation, and x is the variable that we want to find out, and we will find out the value of x according to a special formula. When a, b, and c in this formula are the coefficients of the quadratic equation, and x is the variable that we want to find out. And actually, in our specific quadratic equation, a equals to 2, b equals to minus 7, and c equals to minus 225, and the variable x equals to r. R is the variable of our quadratic equation. So we have all the values of all the variables in the special formula. We put the data inside the formula, and we found out that the radius of the semicircle is equal to 12.5 units, but we have also the second solution. The second solution is that the radius of the semicircle equals to minus 9, but it is impossible that the radius of the semicircle, it is impossible that it is a negative number, it must be a positive number. So this answer is not correct, it is cancelled, and we left only with the possibility that r equals to 12.5 units. So the diameter of the semicircle is 2 times the radius, it is AB, and 2 times the radius is 2 times 12.5 is 25 units. So the final answer to the question is that the diameter of this semicircle is 25 units. So D equals to AB, D is the diameter, equals to AB equals to 2 times the radius, it equals to 25 units. Okay, thank you very much.